Example 13.6, Part C, wants us to get the answer to the division problem as well as state the quotient and the remainder. So here we have a division problem where it's already written in fraction form. And one of the things that I want to caution about when it comes to setting up the division problem is you want to be careful about missing terms. So this numerator is a degree 3 polynomial, and I can see that because the largest power I have on any variable is 3. So typically, if I have a degree 3 polynomial, that means that I would have an x cubed term, an x squared term, which I have both of those, but I typically would also be allowed to have an x term. Since there is no x term here, I'm going to put plus 0x as a placeholder. So I'm going to make a comment here that this 0x, that represents a placeholder. Now, it's not absolutely necessary to have, but I do find that it is a good habit to get into purely for organizational purposes. It will help prevent you from making little errors in the long division process. So I'm asking you to trust me on this. It is a good thing to do. And if the divisor needed the same thing, I would do that. The divisor is degree 2. I can see that from the leading term 3x squared. But this one's not missing any vital pieces. It's or vital terms. 3x squared minus x minus 3. That's exactly what we would expect out of a degree 2 quadratic. So with that said, now I want to go ahead and set up the division problem. We have the divisor 6x cubed, or excuse me, the dividend 6x cubed plus 13x squared plus 0x minus 15. And then our divisor is 3x squared minus x minus 3. Create a little section for scratch work. And now we'll get started. So we're going to take 6x cubed and see how many times 3x squared will divide into that. That will end up being 2x times. So here's the first benefit of that placeholder. It gives me a place to put 2x in the quotient line lined up with the terms that are in the dividend. Then we're going to do our multiply the entire divisor with 2x. That's going to result in 6x cubed minus 2x squared minus 6x. That entire quantity will need to be subtracted from the dividend. As we saw in previous examples, if you do it right, the first term will always cancel. After that, the x squareds should become 15x squareds. And then here is the second benefit of having that placeholder. Now I have x's lined up in this last column, 0x with that minus 6x. But I've got to be careful because it's not 0 minus 6. It's actually 0 minus negative 6. So that's going to result in plus 6x. Bring down the constant term, and now I have the expression 15x squared plus 6x minus 15. Let's do one more round. We're going to take the 15x squared, see how many times 3x squared will divide into that, and that's going to end up being 5. That's a plus 5 to join the 2x, and we'll go through another round of that multiplication. So 5 gets multiplied to the entire divisor there, giving you 15x squared minus 5x minus 15. Subtract that quantity from 15x squared plus 6x minus 15. First term cancels, and we actually get a bonus cancellation here. The constants of negative 15 are going to end up canceling out as well. That doesn't always happen, but when it does, take it. and then we add up the x's, and we should end up with positive 11x. So this takes us to the end of that long division process for this example, where we can say that q of x is equal to 2x plus 5, and r of x is equal to 11x. The other thing that I will do is write out the answer to the division problem. So we were taking 6x cubed plus 13x squared minus 15, and we were dividing it by 3x squared minus x minus 3. So that is going to be equal to the quotient plus the remainder over the divisor. I'll box that in as the answer to the division problem.